So far in our topic of polynomials, we have learnt about this very useful remainder theorem that saved us a lot of work when we were dividing a function by a linear function of the form x minus a, and by substituting in the value of a, we got what the remainder was. We also established that when we're dividing, we can have two situations. We can have a situation where there is a remainder or where the remainder is zero, and that means that if the remainder is zero, then the thing that we're dividing by, our divisor, is a factor of our original function or polynomial, as we're dealing with here. And that leads us to another little useful theorem called the factor theorem. And it comes in two parts. If x minus a is a factor of a polynomial, then that leads us to conclude that the remainder is zero. The other way round, if the remainder is zero, then that means that x minus a is a factor of the polynomial f of x that we've been dividing into. This can be combined using a very useful piece of mathematical notation. This symbol here, make a note of it just now, please. We're going to be using it a lot in the work that we do, and that is read as is equivalent to, and it's a double implication. It means that x minus a is a factor of the f of x, implies that the remainder equals zero. Or reading backwards, the remainder equals zero implies that x minus a is a factor of the f of x. If we look at an example here, show that x minus 2 is a factor of the f of x, the f of x being x cubed minus x squared plus 5x minus 14. We use our remainder theorem by substituting 2 into our function. And then our factor theorem concludes that the remainder is zero, therefore, or that implies, notice we're using part of the is equivalent to symbol now, implies that x minus 2 is a factor. This is a show that question, and so it's the same as you had when you were in Nat 5. If it's a show that question, you must finish your answer with a statement describing what your working actually shows. So this working here shows that the remainder is zero, and that implies that x minus 2 is a factor. And that is the factor theorem.